Hello everyone, in today's video you will understand what is linear transformation is. So let's start from the very beginning, from the definition. Let V and W be two vector spaces over field F. Then a function phi is called a linear transformation from V to W if following conditions are satisfied. Look, we have basically two conditions. The first one is additivity, where phi of two vectors is equal to sum of two transformations individually. And also we can take this constant out of brackets, so this is homogeneous, yeah, I forgot this English word. So yeah, and we can write these two conditions, this system, as this one big formula. So in this formula you have these equations, and of course for any x and y belongs to V and our scalar belongs to field F. And this is not really important. By this thing we denote the set of all linear transformations from V to W. So let's before that I need to say, oh shit, why is it add like this? So sorry guys. Before that I need to say that this video is really important to understand linear transformations. Check this from the channel 3 blue 1 brown. It's really good video, you will understand the whole thing. So let's take some practice and determine which of the following functions are linear transformations. We need to check if it's linear transformations or not. So we have the first example from two-dimensional space to three-dimensional. So we can call two random vectors, say it's vector A, which equals to A1 and A2, and vector B, B1, B2. And yeah, it's from two-dimensional space, and two-dimensional dimension, of course, not space, dimension, two-dimension. So phi of these two vectors, is it sum of two vectors individually? Let's check if it's true. It's our first criteria for linear transformations. So by basic rules we can say that the sum is equal to the sum of two vectors is equal to coordinates, the sum of coordinates each vector correspondingly. So I hope you understand it. And phi of transformation, let me call it actually transformation. It's phi, but I will say transformation. Transformation of A plus B. We just say that that A1 plus B1 is equal to X and A2 plus B2 is equal to Y. So the transformation of vector A plus vector B is equal to A1 plus B1 plus A2 plus B2, and yeah, as you can see we just subtract variables into this linear transformation. So we found the left hand side of our equation, and now let's do right side. Phi of vector A is equal to A1, A2, and one more time we apply this, that a1 is equal to x, a2 is equal to y, so x plus y is equal to a1 plus a2, and x minus 1 is equal to a1 minus a2, and 3x minus 2y is 3a1 minus 2a2. Okay, so we do the same operation with b, and we sum up these two, and one more time sum two matrices, and we need to check if these two things are equal. Yeah, and actually look, they are equal. We can see we need to a little bit movement in this every row, and we will check that they are actually equal. So the first condition hold true, and let's check the second one with scalar. So we have our vector a, and scalar multiplied by this vector is equal to this thing, and transformation of c multiplied by vector a is equal to this, and one more time this is equal to x, this is equal to y. We do the same thing. So, and now we do c multiplied by phi c out of brackets in this case, and as you can see, these two things also the same, absolutely the same. If we multiply each variable on scalar, we got the same, we will get the same matrix as there. So phi of c multiplied by vector a is equal to c multiplied by transformation of vector a. So this is one more criteria, and this means that our expression is the linear transformation. Its transformation is yes, it's transformation in any case, but it's linear, you know, it's linear. We check if it's linear. So also we can check by zero vector, that also holds true. All conditions are hold, that means that this is linear transformation. So number B, and look here, if we substitute zero vector, we will get this an equation that these two matrices are not the same. So that is phi is not linear transformation. I think it's really easy. So number C, we need to check the determinant. Is it linear transformation for any square matrix A of size n? So first of all, let's check additivity. And yeah, this is I wrote a really long expression. Phi of a plus b is two matrices, but we know that we're considering case when n is equal to 1, so phi of these two matrices is actually equal to a plus b. A and b, it is some scalars, so we can write it in this form and find phi of this is apply our transformation determinant of a plus b, and we know that it is scalars, so we can write it separately. And yeah, so this is phi of a and plus phi of b, and this is equal to matrix A, this is equal to matrix B, and transformation of a plus b is equal to transformation of a plus transformation of b. So additivity holds true. Let's check the number two criteria, and I don't want to call it like, yeah, you can just see on it and understand it. I think it's quite clear. So for n is equal to 1, it's linear transformation. Yeah, it is. And case when n is more than 1, look, when we cannot write determinant like this. We just cannot do this. Look, the determinant a plus r, it's not equal. So it's not equal. So at least one condition is false, then this is not linear transformation. Therefore, for any matrices which with size n is more than 1, it's not linear transformation. And the last one is D, where we have transformation trace of matrix. If trace, it is the sum of all variables on diagonal of matrix. Yeah. So phi of two matrices A and B is equal to trace A plus B, and yeah, we can write it like this. And so yeah, guys, I think it's like trivial a little bit. It might seem like it's trivial, but it's normal. It's normal. Transformation of C, it's transformation, it's trace, sorry guys, it's trace, of course, trace of C multiplied by A, and by the properties of trace, we can write it in this form. So yeah, you can check it, it's really easy to prove. So hence it is linear transformation. I think you understand it, and one more time, this video is really important, and also I watched this one. It's also helped me a lot to understand linear transformations. Thank you guys for watching, like and subscribe.